Okay, 7.2b, the second part of 7.2, is determine the equation of a parabola given the x-intercepts. And we actually cover this in chapter 6 a little bit. But in chapter 6 we were looking for a specific equation, specific function that had x-intercepts along with a certain point that it had to pass through. Here we're only going to be looking at the x-intercepts, so there's more than one answer a lot of times for the equation that you can come up with that has x-intercepts, given x-intercepts. So the first little part there just basically says, compares the difference between what we did in chapter 6 and what we're going to do now. So if we're only interested in the x-intercepts, there's a bunch of different answers that we could get, but we're not looking for a specific function like we did in chapter 6 where it passed through a specific point in addition to the x-intercepts. So you can see there that all of these equations here, the red one, the black one, and the purpley coloured one, all pass through the same x-intercepts of -2 and +1, even though they have different equations up here at the top. So if we have the x-intercepts, you should be able to figure out the equation. So the first example here just basically says that if you have x-intercepts of 5 and -4, to come up with an equation that, or a function it said, that has x-intercepts of 5 and -4, we would have x equals 5, x equals -4. So they would be the x-intercepts. So the factors would be x minus 5 equals 0. If I bring that -4, would be x plus 4 equal to 0. So that would mean your factors would be x minus 5 and x plus 4. So your equation that has those two x-intercepts would be x minus 5 times x plus 4 equal to 0. Now that's just left in factored form, but if it asks you to answer it in standard form, you just multiply those factors out. So the equation, the function, could be y equals x minus 5 and x plus 4. Now the second one, if the x-intercepts are 0 and 5, -5, then the factors will work backwards. That would just be x, and this would be x plus 5. Because you basically think about solving each factor equal to 0 to get those x-intercepts. You'd bring that -5 back over and make it x plus 5. So your equation would be x times x plus 5 equals 0. And the function would just be with the y in front instead of the 0. X times x plus 5. That function would have x-intercepts of 0 and -5. Now sometimes the x-intercepts aren't real nice numbers, but you can still use the same process to find the function that has those x-intercepts. So if we have x-intercepts, x equals -1/2 and x equals 3, then if I don't like having the fractions there, I could multiply both sides by 2 to get rid of the fraction, because multiplying both sides by 2 would give me 2x equals -1. And then basically if I bring that 1 over, make that 2x plus 1 equals 0, that would be my factor, 2x plus 1. And this one here would be just x minus 3 equals 0. So your factors would be 2x plus 1 and x minus 3. So your equation would be 2x plus 1, x minus 3 equals 0, and a function would be y equals 2x plus 1, and x minus 3. And again, it doesn't say that you have to write the equation in standard form, so you can leave it in factored form. If you're asked to write it in standard form, you just have to multiply those out, expand them. So number 4 says the x-intercepts are x equals negative a third and x equals negative 6. So if you multiply both sides by 3 here to get rid of the fraction, you'd end up with 3x equals negative 1, and then 3x plus 1 would be 0. And this one here, if you brought that 6 over to the other side, negative 6 would be x plus 6 is 0. So that would mean your factors would be 3x plus 1 and x plus 6. So your equation would be, an equation would be 3x plus 1 times x plus 6 equal to 0, and your function would just be y equals 3x plus 1 by x plus 6. And that's it for section 7.2.